Our next speaker on is Serrie-justine Chapman of TVS. She's a requirements engineering consultant and a Shoreline product manager. The title is Managing a Secure Requirements Engineering Flow Within a Complex Family Environment in order to attain ISO 26262 compliance. Serrie worked in pre-silicon verification and requirements engineering within Infineon Technologies for 14 years. She used her skill set to define a tool that would help her achieve requirements completeness and to test end results using her previous experience. She joined TVS in January 2014 and works as a consultant in requirements engineering. She is also a project manager for a Shoreline, a TVS tool that has driven that she has driven to solve the issue of mapping requirements to test results. Okay.
Okay, is this working? All right. Okay. I'm not going to talk about any solutions today because you'll see in the blurb at the beginning in the books that I mentioned about a crystal project. It's a big Artemis European project with 70 companies, including Volvo, Airbus, there's medical in there, Philips and Siemens, and they're all trying to do requirements engineering. I think it was mentioned a few times about the fact that requirements engineering and actually implementing it correctly and getting into tests isn't easy. It's even more difficult when you've got multi-product variants, and we're currently analysing the variant problem. Sorry. So I'm going to just go through some of the points that we deal with in requirements engineering. So some of the words I think actually ought to be looked at a bit more than others, and one of the words is discipline. Requirements engineering is about disciplined approach, and I find that most companies, even the big companies, might be spending a lot of money on this, but they really aren't looking at having a disciplined process and products. So there's four main parts to requirements engineering. I'm going to run through this quickly because he wants me to cut it down to 15 minutes. So we've got elicitation. Elicitation is about going and actually delving into the requirements. Documentation. You'll find that for the standard, the ISO 26262, and in fact most of the standards, they don't tell you how to store the documentation. So it can be on databases, it can be model-based. Model-based is getting very popular in systems engineering. We've also got validation and negotiation. So normally you go through, you get your requirements, you document it, you then go back to your clients or to whoever you're actually interfacing to, and you actually agree it with them. And then the next one is management, and management is the hardest bit. I did see a person recently saying herding cats isn't too difficult, you just use one of the laser pointers. So maybe it's not that difficult. So I'll go through these points. Requirements. So in elicitation, a requirement is a statement of need, clearly and accurately stated. I doubt very many of you deal with clearly, accurately stated requirements unless you've written them yourself for your own purposes. There's two main types of requirements. There's functional and there's non-functional. Functional is about what a product's going to do, so it's feature-driven really. Non-functional requirements are more about smell, cost, taste, whatever, any extras that you might want to put in there. Also, it will be standards and law, etc. And also deals, etc. that you're doing with your customer. The next part you have to look at is stakeholders. So stakeholders identification, you might think it's just that's your customer. It's not. It's you've got internal teams, you've got external teams. It might be your competitor, because your competitor might actually be putting something in that you might be vaguely aware of. And although it's not out in the market, they may be one of your stakeholders that drive your requirements. You also need to have a clear identification of what role they're actually taking, what's the responsibility. Are they going to supply you with the requirements? Are they going to turn around and have a particular manner of dealing with you, etc.? Who's going to turn around and be responsible? For example, in the ISO 26262, who's responsible for taking on the safety? Is it the point of your supplier, or is it your... Sorry? I can't see it. Can you go on to the next one, please? Okay, and requirements engineers, which is what I am, they're there to help you, honest. This is going to go a bit slow now, can you just... So validation negotiation. So there's one thing called the requirements quality gateway. This is about the validation time. So this is where you review. You might want to just do a review Depends on how big your product family is and how many requirements you've got. If you've only got 5 requirements, don't go and buy a big tool like doors. There's a thing called boilerplates. That's about helping validate. There's some tools out there like the reuse tool, which looks at the quality of requirements. You might want to use something like that. At this point also, you may have conflicts from multiple stakeholders. You're not always going to be able to solve them, so you may have to negotiate with them and see basically what suits you and them the best. Okay, there's another thing inside the ISO 26262, and that's called the Development Interface Agreement. So there's a top-level one called the HARA, which is the hazard analysis, and that assigns each of your components certain safety features. Your DIA is your development interface, so this is telling you how you're going to deal with your customers. So you agree who takes responsibility for things, how you're going to deal with it, what format they're going to be in, how your documentation looks, etc. So you might have extra security built in on certain customers, for example. The next big problem that you do have is communication. Now, communication is a problem in this industry generally, but it's definitely a problem with your requirements. So there was a standard that came out through automotive, which is called RECIF, and that is an XML schema essentially. That means that, I mean, in the past I've heard of people that have been told by their customer that they have to go and buy doors. Now, a lot of smaller companies don't want to go and buy a big tool like doors because it's an expensive tool to manage and it's complex. So RECIF came out so that you can't dictate to anybody what tools they use. So if you're a supplier, you could use PTC Integrity or you could just use RECIF and translate it into your own tool. So there is an exchange process that is agreed in there called the HIS exchange process. I haven't seen anybody using this yet, but that might be one of the communications that you might define between on your DIA. There's a few things that you have to be aware of when you're actually communicating with data. One is loss. You have to make sure that your data is complete, and you might have to set an extra process in place to ensure that you've got completeness. Data integrity, a lot of the problems that we see with the tooling and requirements engineering down to test that the data might not be there. So data integrity, that's about ensuring that we haven't got any corruption. Metadata is very, very important in requirements engineering. You have to know in 20 years' time who exactly stated that requirement, who changed it, why did it disappear, are you responsible for all those deaths? That's essentially what this standard is about, is who is responsible. So it's very important that you ensure that you don't get any corruption. Security, this is actually becoming more of an issue also internally, is that you might have malicious attack, but you don't necessarily see it outside of the company. You might actually see it inside the company. You may have somebody working in your company that does want to maliciously attack your data, so you've got to make sure that the security is there. So it's less about requirements engineering flow, more about support requirements engineering flow. Safety, another part that you might want to agree also when you're doing the DIA is the proof of safety culture. So you're not allowed to turn around and have a culture which is all about money and getting out and getting bonuses. It's got to be related to you actually producing a safe product, and that's actually written into the standard. How you get that proof that one of your suppliers has got a safety culture, you'd have to agree also in the DIA. Okay, documenting the requirements. So I mentioned that it didn't actually state how you had to do this. So there's some options here. You can go for natural language. Natural language seems the most obvious. However, it does require quite a lot of discipline. Most requirements that I've ever seen have been pretty poorly written, even after training groups of people to write them. So the discipline in writing natural language. You also might have to have ontologies because the meanings of words change between different companies, and that's quite common. MBSE is becoming very, I think MathWorks was showing that. So that's model-based systems engineering. Again, that requires tooling, most likely, although you could do it in PowerPoint slide sets, etc. It does need a training and a common understanding. Again, ontologies, because what looks like a model saying one thing to one person might not mean the same to the other. So you could have glossaries, or you might want ontologies. One of the issues I had with the ISO 26262 was that it required a semi-formal notation. It was highly recommended for ASIL C and D. There is no such thing as a semi-formal notation in the English language, although you could argue that the English language itself is a semi-formal notation. They were suggesting using model-backed natural language, so you do models and natural language. Models don't always work at lower levels of refinement, so it's a bit. We have found something called the claims language that was put out there in the IT security ITSEC standard in '91, which is a security boilerplate, and we're looking at extending this within the claims, extending the claims language for safety. It's just taken me 2 years to find the person who wrote that to ask them. Their security was really good. Configuration management and change management, I'm sure you're doing it. You do have to do it as part of the standard. It's very difficult to ensure discipline process on this. Variability management is very, very complex, and because of that we're seeing a rise in middleware tools at the moment in the industry to try and solve that. So requirements tracing, if you look at it, it's quite simple. So you get the requirements, you look at how you're going to implement it, how you're going to verify, and then how you're going to prove it. In reality, it's orthogonal. Your requirements, by the time you've collected them all, are going to look a mess. You're also going to want to go from test plan to test results, and then you're going to map through. So the traceability that somebody mentioned earlier, how you manage all of your tools and your results and your information through your change and your configuration management is actually very, very complex. So now we're looking at the tool ecosystem. So this is what the Crystal project is all about. It's about looking at this tool ecosystem. So if we look at what we're seeing come through, is we have change management. There's lots of different tools out there for that. We then have the requirements management. There's a lot of different tools out there for that. Doors is one of the big players. It's a very, very big tool. But Integrity's in there fighting with it at the moment. Enterprise Architect, Clarion, JAMA. So there's quite a lot of tools in these areas. These ones are relatively new. So Reuse and Quality Centre, that's about doing boilerplates to turn around and improve the quality of your requirements. Then you've got your hardware and your software test tools, which are actually generating a lot more data for you that you also need to map into. You've then got your configuration management tool, which you need to get the metadata to say what you were looking at the time that you were grabbing there. So you have to do snapshots of your entire flow, and that tends to manage it. We've got a lot of solutions coming through, so RECIF, OSLC, UCIS, these are all interoperability standards that are coming through in the industry. And in fact, OSLC has been very heavily driven by the Crystal project. It's web-based. But this is probably what's most interesting at the moment, is you've got these middleware layers. So Rectify has been about for a bit, the Sure Signs our tool. PTC have got something called ThingWorks, Context STM's coming out with Mentor. So a lot of the tools are now about how we're going to get the tools to talk together. In reality, they wanted OSLC to sort this out, but it doesn't seem possible. So one of the things to look at when you're trying to do requirements engineering is your tool choice considerations. There's a lot of ALM or PLM, which are product line management tools, and they are designed for this purpose, but a lot of the things I see is this has come out of the software domain, doesn't suit half of the hardware domain. A lot of it requires a lot of manual intervention, so you're actually copying and pasting into the tool because it doesn't actually interoperate with the rest of your tooling. Data translation movement might not suit you if you have to go for a pure secure solution. Looking for the correct tool for the job. So when I started out, I tried to put all my tools together and it didn't work very well. So I would say that if you really want to think about it, think up front what tool's going to suit you, do they interoperate together, otherwise you've got a lot of pain to go through. So different tool solutions do suit different domains or work environments. You know, if you're using Jira, why do you want to go and buy all of IBM's tools just because it works with their tooling? So if you've been using Jira and you've got legacy and it works for you, don't change it, but find a tool that works with it. You've got to at least make sure there's no conflict on the tooling. A lot of the times as well, when you're looking at tools, you're actually looking at tools that have got quite a lot of overlap. We're trying to avoid overlap if you can, because it means that you're not necessarily using the best solution, or they're not necessarily going to stick together quite so well. Legacy tooling, a lot of the time we go for legacy tooling because it's expensive to move. Extensive tailoring, there's a lot of scripting written around tools, and they're written around tools because tools weren't really fit for purpose, or they haven't become fit for purpose over the years, so you've had to tailor them to suit you. Also, you've got the cost of actually sticking the existing tools together. If it's so expensive that you're almost rewriting the tools themselves to enable them to stick together, then don't use them, go and buy a different one. Costing. Multiple tools are expensive, but also on the ALM solutions, the PLM solutions, there's a lot of hidden costs. So yeah, they'll give you something, but it just doesn't do anything until you buy all the extras. So it has to be considered. It might be high on resource overheads. So if it's hard to use or it's costing you a lot of resources to manage the tool, then I'd consider whether you can afford that. It could be that you can afford it and you can have an entire team, in which case it's a better solution for bigger product families. Overkill. Don't buy tools that have the extras, like I just said. And also, if you've got a small project and only a couple of variants, then use Excel. There's no reason to go and buy tools just because they look nice. So we look at process. One of the things that we did find, and I think a couple of people have hit on it earlier about all the shift left stuff. I know it's the thing with this one. But you can actually do things through process, so it doesn't have to be done through tooling. So if you've got a requirements database, that could be an internal database, it could be an Excel spreadsheet, and you take out a variant. What we found is that we could push out, so we've got a SureSign, which is our test management tool, and then we've got a target spec. Originally, we waited for the target spec, which is the documentation being written by the specification guys, and then we waited, and then the verification guys got hold of that spec, and then had to work out their test bench. But one of the things I did find was that the guys writing the specification like to have quite a lot of wriggle room, because they don't really know what they're going to design up until they've actually got into the design. So therefore, the verification guys very dependent on having a very clear spec, but the specification guys aren't very clear about what they want to write yet, so therefore it becomes a little bit of a problem. If you give them both a set of requirements at the same time, you can get the verification guys can start off a lot earlier, because you roughly know what you've got. You haven't got the full spec yet, but you roughly know what your test bench is going to look like. You then finally receive your specification, probably quite late in the process, from the design guys, but then you can start asking questions. So if in the target spec you see but you don't see it mapping to any of your requirements, then you've got to ask whether that feature should be there. It's either going to be a missing requirement in your database, so you take it back up to the management, you go up for your change management process, and you say, well, hold on, he's written a feature or she's written a feature, and I don't see it in my requirements. Is it a missing requirement, or are they over-engineering? So you can hit out the over-engineering. Again, if you see an implementation that doesn't seem to map what you thought was that requirement, then you can say that it's ambiguous. Again, you take it through change management. Same again, if you've got verification items and they haven't written it into the target spec, they might not necessarily need to have them in the target spec because they're verification requirements, but you should start putting those into your requirements database and giving yourself some reusable internal requirements. I am almost there. So I just have a look at some of the things that we need to consider. So you need to gather your requirements, you need to map them into your test. This is obviously my tool here. And then you need to map them to results. Now you don't have to automate it. I've driven the tool to automate it for me because I had such a big problem. You've got to also ensure that there's metadata there. So you need to gather what's changed, what files you're looking at, and your metadata about who did it. And you also probably want some visibility over cross projects. So you might want to just turn around and be able to visibly, so for the project managers it's very good for them to actually see the requirements over the entire product line rather than just a single product. So,
Okay, thank you, sir. Right. Are there any questions for Serrie? Yeah, Martin.
Martin Lampard, Cadence now. You mentioned the fact that requirements try to remain fluid for as long as possible. In your experience, do people sort of measure sort of late requirements churn, and how much of that is normal? And what are the signs of it?
It's a bit too normal, yeah. Especially in hardware, because you seem to. I mean, in reality, the pictures that we saw earlier, especially from MathWorks, about doing the shift left and actually spending quite a lot of time on your requirements. If you want to automate, you want to have as few changes as possible, the churn actually costs you the most, and it also loses your customers at the end of the day. I haven't seen any of the companies, I'm working with 70 companies, who have got a clean flow with that. They've all got late churn, they've all got late bug funds, and they all blame it on requirements.
But do they actually track it, or do they just sort of pull their hair out and say, oh, that's why?
A lot of them have got internal tools. No, they all just talk about what a problem it is, and they're trying to look to solve it. We still haven't found in reality, the companies have got to put some money into it, really,
Right.
and it's buying into it.
No, thanks.
Martin, anything? Anyone else? Okay, thank you very much, Serrie.